Page 7 of functions. On page 64, the reading says that this is a composite function, f of g of x, or f composed with g of x. So basically this means g operates on x first, and then after that f operates on g. How is this expression read? The way the book reads this is f following g. F following g. And that's a good way to remember that the g happens first and then the f is operating afterwards. It means that first g operates on x and then f operates on x. Draw this composite function as two connected function machines below when f of x equals x to the fourth and g of x equals 2x plus 3. So let's take your initial input, which is x, and then it gets fed into the first box of the function machine, which is, of course, g, right? G operates first. And the g of x function machine is, it takes 2 times the input and adds 3. And then the next box, which is the f box, takes the output of the g box and it takes the fourth root of whatever comes in here. Okay? F follows g of x is the same as f of g of x. And g follows f of x is the same as g of f of x. So is f of g of x equal to g of f of x? Use the example above to check. Okay, so first what we're going to do is we're going to figure the output of this one. So first you put in x, and then here you're going to have 2x plus 3, right? And then you're going to take this and you're going to put it in x to the something to the fourth function, or x to the fourth function, and you're going to get 2x plus 3 to the fourth, right? What if you do this in the opposite order? First we'll do f, and then we'll do g. What happens then? So first you're going to have something to the fourth, x to the fourth. And then you're going to take that and you're going to put it in the other function machine, 2 times something plus 3, and then you get 2x to the fourth plus 3. And then we're going to compare f this order, first f, then g, and then we compare that with the first g, then f order, the opposite order, and we check to see if it's the same. And it's not. So, is f of g of x equal to g of f of x? No. Okay, we just showed it. We chose one function, or a pair of functions, we reversed the order, and we already showed that no, they're not the same thing. Okay. Problem 1. Given the function 2x plus 3 and 1 minus x, find in simplest form f follows g. Okay, so first we're going to do g, which is 1 minus x. And then we take the 1 minus x and we put it into the input here, which is the x here. So it's going to be 2, 1 minus x plus 3. You get it? So first we did g, which is this, and then we did the outside function. Okay? And so if we simplify it, it says find it in its simplest form. It's 2 minus 2x plus 3, 5 minus 2x. Okay. Next one, g follows f of x. 1 minus, So the first thing we're going to do is we're going to do the f function first. So that would be 2x plus 3. And then that's going to go into the g function, because g follows f. And that's going to be 1 minus something, right? The something being 2x plus 3. Let's simplify that. 1 minus 2x, we're going to distribute the negative sign here and here. And then we're 1 minus 2x minus 3. And so that is equal to negative 2 minus 2x. Okay. C. F follows g. And then we're supposed to put negative 3 in for x. But first, we already know f follows g. F follows g is that. It's 5 minus 2x. 5 minus 2x. And we're going to put in for x negative 3. So we're going to put in 5 minus 2 times negative 3. So that's going to be 5 plus 6. 11. Okay. 2. Find f of x, given f of x equals 2 plus x and g of x is 3 minus x, find f follows f of x. So first we're going to do f, which is 2 plus x, and then we're going to put that into the input of x, which is 2 plus x. So if we simplify that, it's going to be 4 plus x. What about f follows g? So g would be 3 minus x, and then if we do f after that, it would be 2 plus something, and that something is 3 minus x. And that we'd simplify that, we get 5 minus x. Okay. How about g follows f? So first we start with f, which is 2 plus x, and then we do g, which would be 3 minus something. And we simplify that, it would be 1 minus x, because the negative sign we can distribute to these two, right? 3 minus 2 is 1 minus x. Okay. Number 3. Given that f of x is the square root of 6 minus x, and g of x is 5x minus 7, find g follows g. So first is g. G is 5x minus 7. And then we plug that into the input of g, and we'll get 5 times something minus 7. And then we're going to simplify. 25x minus 35 minus 7 is 25x minus 42. Okay, and then what about f follows g, and then we plug in 1. So first we do g, which is 5x minus 7, and then we plug that into the f function, which is 6 minus the square root of, okay, and then we're going to simplify that, so we have, we're going to distribute the negative sign. So it's going to be 6, let's see, square root, 6 minus 5x plus 7, so 13 minus 5x. And then we're going to put in x equals 1. And then we're going to get 13 minus 5, which is equal to the square root of 8. Now what about g follows f, and then plug in 6 for x. So first we'll do f, which is square root of 6 minus x, and then we're going to operate g on that, which is going to be 5 times something minus 7, the something being square root of 6 minus x. And then we're going to put in 6 for x. If we put 6 in there, we're going to get 5 times square root of 0 minus 7, which is equal to negative 7. Alright, last one. Given that the function f is x squared and the function g is 2 minus x, find g, f follows g. So first we're going to do g, and then we're going to do f, which follows it, so it's something squared. So, and then, so that's f follows g. Now let's do g follows f. G follows f would be x squared first, and then we put that into 2 minus something for g. Then find also the domain and range of f follows g and g follows f. Okay, so this would be equal to I'm not sure if it helps, but let's multiply it out with FOIL. Something like that. What about this one? 2 minus x squared. Okay. And then we find the domain and range of each one. So the input of f follows g would be basically any real number. And the input of this function, let's take a look at this. What kind of values can 2 minus x squared take on? Well, the result of this is never going to be a negative number because it's something squared, right? Can it be as small as 0? Yes, if x equals 2, it would be 2 minus 2, which is 0. So it could take on the value of 0. It can never be negative. So basically, the range is, the range would be any number greater than or equal to 0. Okay. What about G follows F? So the x value is going to be any real number. And then what about 2 minus x squared? Yes, that can be negative. It can be quite negative, right? And it can even be a little bit positive, right? If you put x as 0 in there, then we're going to get 2 minus 0, right? Now, can we get any number bigger than 2? I don't think so, because like no matter what you put in for x, you're never going to put anything that's going to make it negative. So like the biggest you're going to make 2 minus x squared is 2, right? You can put in 0 for x squared, but anytime you put in any number besides 0, you're going to get a positive number out of x squared, and it's going to make 2 smaller. So y is smaller than or equal to 2. Okay. And that's it. I'd like to show just one more way to solve for the range of these. We could, again, find the vertex, and then based on the vertex and the a value, we can see whether it goes up or down, and then find the range based on that. Okay. Let's do this one first. It's easier. So 2 minus x squared. What's the a value here? Well, the a value is, let's write it in order that we usually see it. So the x squared term first, and then the last term. So this is the function. It's a quadratic, of course. So if we look at this, then we can see that the a value is negative. So that means that the parabola opens downward, right? Now, what about the vertex? What is the y value of the vertex? Well, we know that the x value of the vertex is negative b over 2a, and negative b is 0, right? There's no something x term, so b is 0. So we already know that the axis of symmetry, or the x coordinate of the vertex, is 0. What would be the y coordinate of the vertex? It would be negative 0 plus 2, which is 2. So we know that the y coordinate at this point is 2, and we know it goes down, so it should be y is less than or equal to 2. Hey, that's what we had there, right? So we just proved that. Okay, what about this one? In this case, let's see, we multiplied it all out. Let's see what the axis of symmetry is. It's negative b, which is plus 4, divided by 2a, which is 2 times, remember the a is this 1 right here, right? If we write it in the order we're used to, it would be x squared minus 4x plus 4. So the b term would be negative 4, and the a term would be 1 here. We have a hidden 1. So it would be divided by 2a. 2. So our x term for the vertex is 2. If we plug it into the equation, we find out that the y term is equal to 0. So the vertex is 2 comma 0. So that means that, what about the parabola? Does it point up or down? Well, look at the a value here, plus 1. It points up, okay? So basically it's like 2 and above. So 2 and above would be, the y value is 0. So it's going 0 and up. So the y value will be y is greater than or equal to 0. Hey, we just checked out that value, right? For this page.